Figure 1 shows a sketch of the curve C, which has equation y equals e to the x root 3 sine 3x from x equals minus pi over 3 to pi over 3. Find the x-coordinate of the turning point P on C, for which x is greater than 0. Give your answer as a multiple of pi. Find the equation of the normal to C at the point where x equals 0. So here's the a question then. Let's have a little look at it. Okay, find the x-coordinate of the turning point. So we're going to need the turning point of this. So we need dy dx, don't we, to get the turning point. So product, the constituent parts are also functions of a function. So let's proceed then. It's u multiplied by the v dx. Sine goes to cos, sine of something goes to cos of something, multiplied by the something differentiated, which is 3. That's where we use the function of a function rule, plus v sine 3x times du dx. So differentiate this then, e to the something differentiates to e to the something, multiplied by the something differentiated, and that differentiates to root 3, doesn't it? Okay, so that's dy dx. Okay, the turning point will be when dy dx equals 0. So what have we got here then? Well, the x root 3 is non-zero, so that will cancel. And we can see that 3 cosine 3x. And then the sine 3x can come over the equals, is equal to minus root 3 sine 3x. So divide by cosine then, and see what we get. And also I'm going to divide by cosine over here, so that's tan gives. So I might move the numbers around as well. So let's move the cosine underneath and write it from right to left. So that's tan 3x is equal to, and I'm going to move the root 3 underneath the 3 over root 3, and the minus I'm going to take over with it and put it up there. That's minus root 3. Okay, so that's good. So now we're told the interval of x is between here. So for 3x then it's going to be triple this, so minus pi is less than or equal to x is less than or equal to pi. And to be honest, we were actually looking for the value when x is greater than 0, so the positive side here is all we're interested in. This is 3x, isn't it? Okay, good. So tan 3x, let's draw a circle then. So trig equation, CAST. Tan is negative, tan is positive here and here. So it's negative there and there. Draw 2 lines. Mark off alpha, the associated acute angle, and simply write tan alpha equals the value without the negative. So alpha then will equal tan of 60, so it's pi over 3, isn't it? 60 degrees is root 3. So alpha is pi over 3. So we're looking for solutions between, on the positive side, between 0 and pi, aren't we? So we're only interested in this solution here, which is round pi back pi over 3. So the 3x then will equal around pi back pi over 3 is 2 pi over 3, isn't it? And that tells us then that x is equal to 2 pi over, move the 3 down to be with the other 3, 2 pi over 9. So there's the x-coordinate of the turning point then, as a multiple of pi. Find the equation of the normal to C, where x is 0. So let's use dy dx then. At x equals 0, dy dx rather is equal to, so I'm going to look at this whole line here. E to the 0 is 1, cos of 0 is 1, so we've got 3. Sine of 0 is 0, so all of this is 0, so dy dx is equal to 3. And we know it goes, this thing goes through the origin, doesn't it, from the sketch. And we'll just verify that if we put 0 in here. Sine naught is naught, so y is naught. So dy dx equals 3 and y equals naught. So y minus naught then is the point, is equal to the gradient of the normal, which is minus 1/3 x minus naught, isn't it? That tells us that y is equal to minus x over 3 is our gradient of our normal through the origin, the normal to C.